Hello student. So today we'll see the ER2 relational mapping for the company database. The company database that we have already got the ER model. So we'll be using that ER model, and then by using that ER model, from that particular ER model, we are going to map it one by one by means we will follow the steps that I had given you in the previous class, and then by following the steps we will be constructing the corresponding relational model for the company ER model. So you have to see the company ER model here. For this particular, in order to follow the steps, you have to see the company ER model that I have given you as a class note. Okay, so and then steps, the first step, let us just see the first step. In the first step, it says that it is the mapping of strong entity type or the regular entity type, isn't it? So from the company diagram, we can see that there are three entity types which are strong, isn't it? The first one is the employee entity type, and then we have department entity type, and then we have project entity type. So these three entity types that the first thing we need to do in the first tab is to convert it to its corresponding relational representation. Okay, so for that we will follow the step, and according to the step, for the employee this one relation, for the employee entity type we will create the employee relation. For the department entity type we will create the department relation, and for the project entity type we will create a project relation. Okay, we'll give the same name. If you want, then you can change the name also, name of the relation. You can change the name of the relation, you can change the name of the attributes also. Okay, so but here I'm using the same names, same means the entity type names, I'm using it as the relation names uh, as well. Okay, means I'm using the same names. So for the employee relation and the attributes, I'm going to I'm going to have the attributes which is there in the ER model as the attribute for the employee entity type. So all those attributes like SSN, birth date, address, salary, and sex, those things will come here, and also the simple components of the composite attribute, that is name. There is a composite attribute name for the employee entity type in the ER diagram, isn't it? For that particular name, and the simple component of this name attribute is F name, M name, and L name, isn't it? So we'll just use the simple components, and then we'll put it as an attribute in the employee relation. So we will have F name as the attributes for the employee relation. We'll have F name, M name, and L name. These are the simple components of the composite attribute name, and then SSN, and then birth date, address, sex, and salary, which are the remaining attributes, simple attributes for the employee entity type. Okay, so from all these attributes we have to select a primary key, isn't it? So from the means from the entity type employee in the diagram, we can see that we use SSN as a key, isn't it? Here there are no more keys which can be used as a key, so we have only one key here. Okay, so as we have only one key, that means it will be we have to choose it as a primary key. There is no other option. Okay, so we will choose SSN as the primary key in the employee relation. Like that, we will do the same thing for the department relation also. In the department entity type, we have three attributes, isn't it? Name, location, and number. So here we have to include these attributes in the department relation. But one thing we need to see here is that, and we have to include only simple attributes and components of composite attributes, but nothing is mentioned for the this one multi-valued attributes in step 1. So we will just ignore that particular uh, uh, this one multi-valued attribute location for now. Okay, for now. So we will have only two attributes for the department relation, and one is dname and dnumber. So here I have changed, there is some changes I have made in the attribute names, but you can use the same thing here also, or you can either change it or you can use the same name that we have used in the ER diagram. Okay, so department has two attributes, dname and dnumber. So from the ER diagram, we see that we name, we have two keys. One is name and number. So from this two key, you have to select only one and use it as a primary key. So I have means I have chosen this d number as the primary key for the department relation. Okay. Same like this means for project also, we'll do the same thing, and then we'll insert all the attributes, simple components of composite attributes, and then simple attributes in the project relation. There is no composite attribute, there is no multi-valued attributes, so there are only three simple attributes, and we have to insert all of them. That is p number, p name, and then p location. Okay, so from p name and p number, we have to choose any one of them as a key. So I'm choosing p number as the primary key here for the project relation. So this is the resultant of step number one. There might be some changes that we have to do in this resultant relations in the latter steps, but for this particular step, we have this three relations, that is employee, department, and then project. After that, by using step number two says that we have to map the weak entity types, isn't it? So in the ER diagram, we can see that there is only one weak entity type, and that is dependent, isn't it? And step number two says that we have to include in the dependent relation for that particular dependent weak entity type, we have to create a relation, and then after creating the relation, the attributes, all the simple attributes and a component of composite attributes will be there as an attribute in the relation. Okay, in the relations also. But another thing we have in the step number two, it is mentioned that the primary key of the owner entity type will become a foreign key in this relation, isn't it? So that's why primary key of the owner entity means primary key of the relation that corresponds to the owner entity type. Okay, so here there are in the dependent weak entity type, we have four attributes: name, sex, burden, and relationship. So we have dependent name here, we have sex, and then birth date, and then relationship. Okay, and another thing, as I have already mentioned you, we have to have a foreign key. Okay, we have to have a foreign key which is referring to the relation representing the owner entity type. Okay, in the ER diagram, there is going to be an owner entity type, isn't it? So from the ER diagram, we can see that the owner entity type or the identifying entity type for the weak entity type dependent is employee, isn't it? So we have already created the corresponding relation for the employee entity type in step number one, isn't it? In step number one, we already have the relation for employee entity type, isn't it? So from this relation, this corresponding relation, it is going to have some primary key, isn't it? Here SSN was the primary key. So this SSN primary key, we have to use it as a foreign key here in the weak, means in the relation representing the weak entity type. Okay, so that's why I have changed the name as ESSN, the attribute name. I have changed it. You can use the same name also, whatever name you want to have, you want to use, you can use it. Okay, but here instead of SSN, I have changed it to ESSN. Okay, and this ESSN is a foreign key referring to employee relation, and it is referring to the primary key of the employee relation. Okay, so that's why it is a foreign key. And another thing that is mentioned in step number 2 is that the combination of the partial key and the foreign key is going to be the primary key. Okay, so that's why I have underlined these two attributes. The combination of ESSN and the dependent name is going to be the primary key for this particular relation. Okay, so that is step number 2. Now let us see step number 3. In the step number 3, we have to map the binary 1:1 relationship, isn't it? Binary 1:1 relationship. So let us see the ER diagram again. In the ER diagram, we can see that there is only one binary 1:1 relationship, and that is Menezes. Okay, Menezes. Menezes is the relationship for which we are going to do the mapping. Okay, and we can see that for this Menezes relationship type, uh, it has an attribute that is start date. We have to means we have to see all these things, all the details. We have to see this, and then we have to represent it in the relational model. So it has an attribute. And another thing about this Menezes relationship type is that the participation constant is total from department side, and it is partial from employee side. Okay, it is partial from employee side, and it is total from department side. So from all the approaches that I had given you, there are three approaches. One is foreign key approach, and another one is merge relation approach, and then the last one is relationship relation approach. So from that three approaches, we cannot use the second option, that is merge relation approach, because what, it is not having total participation from both the entity types participating in the relationship manages. Okay, if it has means if from both direction, if it is total participation, then we can use it, but we cannot use for this particular manages because there is only one total participation. Okay, one is having partial participation. Okay, so we can either use a foreign key approach or a cross reference or relation approach. Okay, so I have shown both of them here, but you have to use only one. Okay, either foreign key or either cross reference relation approach. Okay, so for foreign key approach said that uh, uh, in the relation which is corresponding to the entity type having total participation in the relationship, we have to do some changes. Remember this. The changes that we are going to do is in the relation corresponding to the entity type, giving a total participation in that particular relationship type. Okay, so that means the changes will be done in the department relation. Okay, so in the step number in step number 1, we already created the department relation here. In step number 1, we have already created the department relation, isn't it? So this relation, we are going to do some changes here. We have to insert some more attributes because of this binary relationship that is manages. Okay, and what attributes that we are going to insert here, what additional attributes that we are going to insert here is, one is we are going to insert a foreign key. Okay, we are going to insert a foreign key referring to the other relationship, referring to the other relation corresponding, means it is going to refer to the relation corresponding to the other entity type that is participating in the manages relationship type. Okay, means there are only two relationship type, there are only two entity type participating in this manages relationship type, isn't it? One is department and one is employee. That means we have to insert the primary key of employee here as the foreign key. Here is in department as the foreign key. Okay, so that's why I am having an attribute here as mgrssn. Mgr represents manager. Okay, so name of the attribute I changed it as mgrssn. In the employee relation it was only ssn, isn't it? You can use the same name here. Without mgr we can use only ssn, but I have changed it to mgr ssn, representing the manager ssn. Okay, and here it is a foreign key referring to the employee relation. Okay, that's why it is a that's why the foreign key is the primary key of the employee relation. Okay, other than this foreign key, if manages has some other attribute, some its own attribute, if it has some of its own attribute, then we have to insert it as the attribute in department. Okay, so that's why it has start date, isn't it? It has the attribute start date. So start date I have changed it as manager start date. Instead of mgr, putting mgr, you can only use m start date also. Okay, but I have changed it to mgr start date. So this is the changes we have done in the department relation if we are using foreign key approach. If we do not use foreign key approach, then we are not going to change the department relation. If we use relationship relation approach, then we are not going to change, and we 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 need not do any changes in department or in employee relation. Okay, the only thing we need to do is for the manager's relationship type, we will create a corresponding relation. Okay, and I have shown the relation here as managers. So managers, I am giving the same name. Instead of managers, you can also give other names like department manager or something like that. Some meaningful name you can give, but I'm using the same name as managers. And in the managers relation, what it is going to have, it is going to have two foreign key, one referring to department and one referring to employee. Okay, that's why I'm using d number. D number is foreign key referring to department relation, and mgrssn is a foreign key referring to employee relation. Okay, and the combination of these two foreign key is going to be the primary key of this particular relation, managers. Okay, and because the managers relationship type, this rel managers relationship type have an attribute that is start date, so I am putting the start date here. Okay, here also. So you can either use this cross reference or relationship reference approach or the foreign key approach. Okay, you need not use both of them. It is not means model will be a, the design is going to be a this not going to be a correct design if you use both the approaches. You have to use either foreign key approach or a cross reference approach. Okay, i'm I'm showing both of them doesn't mean you have to use both of them. Okay, so for this particular example that I'm explaining right now, I'm using this foreign key approach. Okay, so just ignore this cross reference or relationship reference relation approach. Okay, so that means we have already done some changes in the department relation. Okay, after that, step number 4. In step number 4, it is about mapping of 1 is to n relationship type, isn't it? 1 is to n relationship type. So there are 1 is to n. We can see there are 1 is to n relationship type in the ER diagram. Okay, the first one is works for, and it is between employee and department, and another one is controls, and that is between department and project, and another one is dependent of. Oh, see, we do not need to do anything for this dependent of. Why? Because we have already done the representation of this particular relationship when we are mapping the weak entity type that is dependent. Okay, when we map the dependent weak entity type, we have already mapped the relationship type that is dependent of, that is identifying relationship type, and the weak entity type is already mapped using step number 2. Okay, so we do not need to do anything for this dependent of relationship type. Okay, and the third relationship type that we are going to map in this particular step number 4 is supervision. Okay, so I'm going to consider the three 1 is to n relationship type. First one is works for, another one is controls, and another one is supervision. And supervision is between employee and employee, remember this. Okay, now let us see. So for the relationship type works for and supervision, step number 4 says that we have to do the changes. There will be some changes will be done in the relation which is representing the entity type and whose participation is n. Okay, maximum participation is n. Okay, so that means for works for relationship type, the n side is employee, isn't it? And again for supervision also, n side, because supervision is a recursive relationship type, so it is obvious that n side is going to be employee. Okay, so for both of this relationship type, that is supervision and works for, the changes we are going to do is in the employee relation. Okay, employee relation we have already created in step number 1 like this. So what changes we are going to do, let us see. So for the works for relationship type, we know that by using foreign key approach, we know that the primary key of the department relation, we have to put it as a foreign key in the employee relation, isn't it? So that's why we have inserted foreign key here, DNO. Okay, and it is referring to the department relation. Okay, DNO. So that is the department number. Okay, and it is a foreign key referring to the department number of the department relation. And this particular attribute, that is the foreign key, is used to represent the works for relationship type. Okay, and then for the supervision, same thing we need to do. For supervision also, we will insert a foreign key. Okay, and uh, this foreign key is referring to the employee relation. Okay, because it is a recursive relationship type, that's why it is referring to the same relation. That's why we know that when some reference things are happening, then and this particular foreign key is referring to the primary key of the reference relation, isn't it? So that's why it is the SSN. This is the SSN and referring to this SSN. Okay, and this DNO foreign key is referring to another means the primary key of another relation. Okay, so that is by using foreign key approach. We can also use relationship relation approach here, and I'm not going to explain it again because we know that for the relationship relation approach we have to create a relation for that particular relationship, and then we have to insert two foreign keys referring to the participating entity types, isn't it? And the combination of that two foreign key will become the primary key of that relation, isn't it? So I'm not going to explain it, and then I'm not using that particular approach here for this particular example. That is for company database, I'm not using. So that's why I'm showing only foreign key approach. Okay, and now the other remaining relationship, that is the controls. Controls is between department and project, and according to the step number 4, we have to insert a foreign key in the project relation, isn't it? In the project relation, we have to insert a foreign key referring to the primary key of department. Okay, so that's why we have a dname here. Dnum here. Dnum is a foreign key referring to the department relation. Okay, so that is step number 4. Mapping of 1 is to n binary relationship type. After that, mapping of m is to n relationship type. For this, we can see, let us check the ER diagram again. And from the ER diagram, we can see that there is only one m is to n relationship type, and that is works on. Okay, works on, and it is between employee and project. Okay, and for such kind of relationship type, that is m is to n relationship type, we have to use the we have to there is only one approach that we can use, and that is relationship relation approach, isn't it? So by using relationship relation approach, we will create a relation for that particular relationship type, and that is works on. So I'm giving the same name, works on, and then it is going to have attributes. Okay, and there will be two attributes, and they are going to be the foreign key referring to the participating entity types. Okay, so we will have P and O referring to the project relation, and ESSN referring to the employee relation. Okay, and the combination of these two foreign key will become the primary key of the relation works on. Okay, and if there is any additional attribute for if there is any attribute for the works on relationship type, then we have to put it here. Okay, so ours was there as a attribute for the works on relationship type, so we will put ours here as an attribute for this works on relation. Okay, so from this, uh, we can say that we have created and we have done so many changes in the relations that we have created in the previous steps. Okay, last step that we have to follow for this particular example is step number 7. Why we are not having step number 6 here? Because step number 6 is for mapping an array relationship type, isn't it? But for here in this ER diagram for the company database, there is no such relationship type. Okay, if in your example, if there is any an array relationship type, then for that particular relationship type, you have to use the relationship relation approach. Okay, so let us see step number 7. Step number 7, if there is any multi-valued attribute, and then for that multi-valued attribute, what we are going to do is we will create an relation, isn't it? So in the department entity type, we can see that there is a multi-valued attribute, and that is location. Okay, so for that particular attribute location, we have to create a relation, and I have named it as department location. Okay, and you can use the same name also. And for that department location, from step number 7, we can say we can say that in the department location relation, we have to insert a foreign key. There will be a foreign key referring to the relation corresponding to the entity type in which this attribute belongs to. Okay, to which this particular attribute belongs to. That means we have to insert the primary key of department relation as the foreign key here in this particular relation. That's why I'm having a D number here. D number is the foreign key referring to department relation. Okay, and then we have to have the attribute also. This means the same attribute we have to have there in this particular relation. So that's why we have the location. Okay, so the combination of these two will become the primary key for this particular relation. Okay, now I'm using only the relational schema here. For designing, we have to use the relational schema. We do not need to have the data that will be inserted in the database. Okay, we do not need to represent those things. Okay, the only representation we need to do while designing is, for designing we need to use only the relational schema. Okay, So that's why I'm using only relational schema here. Relational schema means what? Relational schema means the relational name of the relation, and then the attributes of the relation, isn't it? So that is showing here. So this thing and this along with this is the relational schema, okay, for that particular relation. So for designing you have to use the relational schema only, okay. So these are the steps we have to follow for mapping ER diagram to relational model for the company database. At last we got this. This I will give it as a class note. That this will be there in the class note. So you can, if you can't see clearly here, then you can see that class note. And means we have, from all the steps we have created 1 2 3 4 5 6 relations, okay. That is employee relation, department locations relation, and then project relation, works on relation, and dependent relation, isn't it? So I'm just summarizing that particular means all the relation that we got in this steps, okay. By following the steps, whatever relation we got, I'm just drawing it again here, okay. So for employee we have these things, for department we have these things, this thing, this thing, this thing, and these things, okay. So these are the relational schema that we got after following all the steps. At the end of the steps, we got this. Okay. The only difference here that I have not yet explained is the arrows. Okay, the arrows that I'm using here. So what does this arrow represent? This arrow represent the foreign key primary key references. Okay. So your arrows are from the foreign key to the referred primary keys. Okay, so you can see that here we have, here in this particular relation employee, we have two foreign keys. Okay, one is super SSN and one is DNO. So super SSN is referring to the SSN of employee. So that's why it is having an arrow from here to here, okay. So arrowhead will go to the primary key, referred by this particular foreign key, that is super SSN. So arrow will go from foreign key to the primary key, okay. And another foreign key is DNO here, this one. So DNO will go from here to the department number, D number for the department relation, okay. Same thing for this department relation, and the only foreign key is mgr ssn, and mgr ssn is referring to ssn, that's why there is an arrow from here to here, okay. And for department location, D number is a foreign key, so D number is referring from here to here, okay. There is an arrow from this one to this one. And again in project, dnum, again this dnum is a foreign key, so there is an arrow from here to here, okay. And for works on, PNO is the foreign key, so there is an arrow from here to here, and ESSN is also a foreign key, so there is an arrow from ESSN to SSN here, okay. And for dependent also, there is only one foreign key, that is ESSN, so there is an arrow from ESSN to the SSN for in the employee relation. Okay, so this is the overall relational model for the company database. Okay, whenever we say a relational model, then we have to show the relational schema. If you want to show the data also, you can put some one or two data, but it is not means uh, possible. It is not possible to have all the data in a relational model. That's why we are only having the relational schema in order to represent the relational model, okay. So that is relational model, and then we see ER model to relational mapping, and from the next class onwards we will see SQL, that is structured query language. Why? Because before, means if we see relational model, then we have to see relational algebra and relational calculus. Okay, so the next topic should be relational algebra and relational calculus. But for your lab classes, so you have to start your lab classes, so that's why before going to relational algebra and relational calculus, I'll go straight to the SQL. Okay, but you have to remember this, before SQL there was relational algebra and relational calculus. So you have uh, the, means after knowing relational algebra and relational calculus, you have to know the structured query language. Okay, means the uh, we have to follow that thing, in but because of your lab classes I have to start a structured query language, because only then it is possible for starting the lab classes. Okay, so in the next class we'll start structured query language. And for this particular mapping, I'm going to give an assignment that will be your assignment number 2. And in that assignment, I will provide requirement specifications for some of the databases. Okay. And for those requirement specifications, you have to design the ER model. Okay. You have to design the ER model, and you have to, from the ER model, you have to map to its corresponding relational model. Okay, so I'll give the assignment today itself.